Hello there and welcome to A2 Maths on Specimen Paper 1, and here we're looking at question 6, a quadratics question. So figure 2 shows the entrance to a road tunnel. The maximum height of the tunnel is measured in 5 meters and the width of the base of the tunnel is measured as 6 meters. Figure 3 shows a quadratic curve BCA used to model this entrance. The point AOB and C are assumed to lie in the same vertical plane, and the ground OAB is assumed to be horizontal. Find the equation for the curve BCA. So this quadratic curve here that's on the right hand diagram, we need to find that equation. So the best way that I could think about doing it, having had some thought about it, is just by writing y equals ax squared plus bx plus c, where that's the equation of a general quadratic. And we know it goes through 3 coordinates. We know it goes through, well, the height is 5, so it goes through the coordinate 0, 5. Point A, well, that's 6 meters width, so that point A is going to be minus 3, 0, and then point B is going to be 3, 0. So we know it goes through these 3 points. We can plug the 3 points into this equation here. We've got 3 variables to work out, and therefore it should be pretty straightforward from there. So let's use the 0, 5 coordinate first. The x coordinate is 0, so it's just going to be c, and the y coordinate is 5, so we definitely know that c is equal to 5, and I'm going to use that going forward from here. Let's now use the coordinate b, so it's going to be 3, 0. So plugging this in, the output for y is going to be 0, so 0 equals a times 3 squared, so that's 9a, plus b times 3, so it's going to be 3b, and then plus on the 5 afterwards. Okay, so that's the second equation. This third equation is going to be from the coordinate minus 3, 0. So again, the y coordinate is 0. X squared, now minus 3 squared gives us 9a, and then b times x is minus 3, so that's going to give us minus 3b, and then it's going to be plus 5 again. Now, in this case here, we have a simultaneous equation that we need to solve. Let's first start by adding the parts together. So 0 adds 0, that's 0. 9 adds 9, that's 18a. 3b plus minus 3b, that will cancel out, and it's going to be 10 on the other side. So it's going to be minus 10 equals 18a. Divide that by 2, so it would be 5 and 9, so it's going to be minus 5/9 as our value for A. And then we can work out our value for B, maybe by subtracting the equations from each other. And if we subtract the equations from each other, we're going to get 6b, well, that's going to just equal 0, isn't it? So b here is going to equal 0. So therefore, the quadratic is going to be y equals minus 5/9 x squared, and then it's going to be plus 0x and then plus 5. So there we are, that's the equation for the tunnel. Okay then, so moving on to part B then, the coach has a height of 4.1 meters and a width of 2.4 meters. Determine whether or not it is possible for the coach to enter the tunnel. Now we're assuming here when the coach is going to stay in the middle of the tunnel, it doesn't have to go just onto its side of the tunnel. So we're going to say that the coach can go down the middle of the tunnel if necessary. So the equation is y equals minus 5/9 x squared plus 5. And what we're going to say here then is that for the x coordinate, we want to find out what the maximum height is going to be. If the width is 2.4, then what we're going to do is we're going to take an x coordinate of 1.2. So x equals 1.2. We're going to find out what this height is for the quadratic curve, and then see if it's less than or equal to 4.1 meters. So substituting in x equals 1.2, y here is going to be minus 5/9 times 1.2 squared plus 5. Okay, so let's now see what this is going to give us. So grab the calculator. It's going to be minus fraction button 5/9 times 1.2 times 1.2 equals, and then add on 5, and that's going to give us a height of 4.2 meters. So the height of the tunnel at the coordinate x equals 1.2 is 4.2 meters. Exactly the same will be the case on the left-hand side as well, because the graph is perfectly symmetric. So yes, the coach can pass through the tunnel. Through the tunnel. As the equation height, or the equation y value, gives a greater value than the height of the coach. Okay, so there we are. Moving on to part C, suggest a reason why this model may not be suitable to determine whether or not the coach can pass through the tunnel. Well, the issue that we'll run into potentially is that if there is a turn in the tunnel. So if there is a bend in the tunnel, then this 10 centimeters of gap may not be enough to fit the bus through. So if there's a bend in the tunnel, the height might not be great enough. Might not be great enough. Okay, so there we are. That's the answer to question 6 here. 6 marks for that one. A bit of thinking about real life situations there is pretty good. 6 marks for that one. Let's now move on to question 7.